more modeling and solving two-step equations. This time we've got a bracket involved as well. This is section 10.4 of Math 8. And to begin, I'm going to ask you to practice modeling the following algebraic expressions, okay? So I've given you 3 expressions here. I want you to model it with those algebra tiles, and then we're going to translate that into algebra using variables. How would you show a number plus 3? A number is like your variable, so we're just going to use a solid rod to represent a number. It's positive. And then plus 3 would be 3 small squares. Remember this stuff? I hope you do. Now, what is this equivalent to with variables? Well, that rod represents, does anyone know? Tell me now. Yep, x, and those 3 becomes plus 3. So x plus 3. Well, how will we do the next one? It says a number plus 3, then all multiplied by 2. So if I were just to focus on this part, a number plus 3, that's the same as above. So I'm just going to copy that down from above. A number plus 3. Then all of this is multiplied by 2. So I want 2 sets of what I see. So this is where I just now double it, or I copy it again. And this is what I have, right? Multiplied by 2. So the whole set times 2. Now, how do we show this with variables? Well, from before, here's our x plus 3, a number plus 3, and then all multiplied by 2. Then all, so I'm going to put a bracket around everything here, and all of it is multiplied by 2. So to show that, I'm going to put a 2 in front, and when there's no symbol between the 2 and the bracket, it's implied that it's always going to be multiplication. So 2 bracket x plus 3 close bracket is represented by a number plus 3, then all multiplied by 2. Now, you see underneath how I said simplified form? How can we simplify this? Well, looking at the model, what do you actually see? How many x's do you see? Right, 2 of them, so 2x. How many 1's do you see? 1, 2, 3, 4, 5, 6. So the simplified form is actually 2x plus 6. Now, in a simplified form is a form that's shown without the brackets. Okay, so these two things are equal or equivalent. Okay, 2 bracket x plus 3 is equivalent to 2x plus 6. Okay, you try C. 3 times the sum of 4 and a number. So how do we show 4 and a number? 1, 2, 3, 4, and a number. The big long rod. Okay. By the way, with variables, that would be 4 plus x. Now 3 times the sum of this, meaning I want 3 copies of what I've just written down or drawn. So here we go. Let's do 3 copies. Here's my second copy. Here's my third copy. And to show 3 times all of this, I'm going to use those brackets again. So bracket, put a 3 in front. And if I ask you to simplify this in simplified form, look at the picture now. What do we have? How many little red squares do we have? 12 of them. Very good. How many x's do we have? 3 of them. So the simplified form is 12 plus 3x. So that bracket is equivalent to 12 plus 3x. Now, when you simplify, or sometimes we call remove the brackets, there's a property that you're actually using. It's called the distributive property. Distributive property. Do you know why they call it the distributive property? Look back at these last 2 examples here. Let me highlight them for you. Here equals to that, and then also that equals to that. Notice what you have where you have the bracket and the number, and then notice the equivalent form without the bracket. How do you think I can go from bracket form to no brackets? Look at here. How do I go from bracket form to no brackets? Can you see something being distributed? Can you see how the 3 gets multiplied by the 4 and that gives you 12, or it's distributed to the 4? And the 3 is also distributed to the x. 3 times x gives you 3x. So that's what the distributive property says. The number outside the bracket can be distributed to both the terms inside the bracket, and that simplifies. So let's not draw models anymore. Let's see if we can simplify just using this thing called the distributive property. So once again, you take the number outside the bracket and multiply by every single term inside the bracket. So what's 3 times x? 3x. And what's 3 times negative 4? That's negative 12. So your answer here is 3x minus 12. Done. Yeah, that's it. So try part B now. Okay. Negative 8 times f, negative 8f, negative 8 times positive 3, negative 24. Done. Don't freak out about fractions. It's the same thing. So 1/2 times y is just 1/2 y. And then 1/2 times 6. Half of 6 is just 3. So there you go. We're done. Okay? So now what I'd like to do is do example 1 and try to do this using Algebra Tiles. And then we'll also do it by using the distributive property in algebra. Okay? Now we'll do the Algebra Tiles first. So how do we model Algebra Tiles? X plus 2. So we'll do the stuff inside the bracket first. X plus 2. Okay? And the 5 means I want 5 copies of this. So I'm going to have to do 5 copies of it. And I'm going to ask you to do that too. So here's copy number 2. Here's copy number 3. Here's copy number 4. And copy number 5. Okay, and this is equal to, whoa, on the other side, 30. Yikes. So I'm going to draw 30. I'm not going to draw 30. Let's pretend it's 30, okay? Now, what you're trying to do, once again, is solve for x, or 1 positive rod. So I'm going to ask you to remove these 10, which means I also have to remove 10 from here. So take away 10. So what do we have left over? Well, we've got 5 rods still, so let me copy these down on the left-hand side. And 30 minus 10 is 20. Now notice I'm going to now try to redistribute these evenly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Remember doing this earlier? Maybe in the previous section. Well, now how do we solve for 1 positive variable? Look, we can group them now very nicely. Hey, group, 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 group. And what do you see in one group? I've got x equals to 4. Done. Okay. I want to show you now this with the distributive property in algebra because I do think it's a little bit faster. But once again, I'm going to parallel this with the model so you can actually see that the model and the algebra are both the same. Okay? So we're going to start with 5 bracket x plus 2 equals to 30. So I'm just copying the question again. And now when you see brackets, you want to remove them by using the distributive property. So let's do it. Okay? You can try yourself too. Distribute the 5, so you get 5x, 5 times 2, that's 10, and this equals to 30. Can you see how that matches this picture here? 5x's, 10, 30. Well, then what do we do next? We take away 10, and that's what I was saying there. And when you take away 10, you got 5x, and then 30 minus 10 is 20. And you see how that matches this picture here? Now, how do we show the grouping? Well, remember the opposite of multiplication is division. So here we have 5x. The opposite of 5 times x is divided by 5. So therefore, What do we have? X equals 2, and 20 divided by 5 is 4. Ta-da! Same answer. Okay? So, why don't you turn the page, and let's try the next one. Okay, I think I've done enough here, so I'd like you to try it first. Okay, once again, stop the tape now so that you can try your own. When you're done, come on back and check your answer. I said stop. Stop, 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 stop. Okay. X minus 5. So there's your X. Minus 5. 1, 2, 3, 4, 5. Unshaded small squares. Gonna double it, so that's 2 copies. So I guess I'm gonna another one, and then 1, 2, 3, 4, 5. This equals to negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Say goodbye. Bye-bye. Say goodbye. Bye-bye. Oh, by the way, this is supposed to be solid. Okay, 2 copies of the same thing. So then we're left with 2 rods equals to negative 2. So we group, and what do we have here? X equals to negative 1. Ta-da! Once again, let's double check this with the algebra, which I think is much simpler. We will distribute the 2 into both. Did you hear me say that? Both x and 5. 2 times x is 2x. 2 times negative 5 is negative 10. Okay, we want to now do the opposite operation, or algebra. So the opposite of minus 10 is plus 10, so we'll do that first. We still have 2x on the left-hand side. Negative 12 plus 10, somebody tell me? It's negative 2, and that matches up with this picture right here. And our last step is to, you guessed it, divide by 2. So x equals to negative 1. Okay? If you got that, give yourself a pat on the back, take a bow, smile, because you get this stuff. Alright, I want to do one more example with you, example 3. But this time, I don't want you to do any modeling with algebra tiles. I just want you to do it with algebra. But I also have thrown the twist in and said, hey, can you solve this question in 2 different ways? Okay. So on the left-hand side, I've copied the question, and let's do the way that we're used to, the distributive property. Okay, so this is using distributive property. And what do we do first? Distribute. Negative 5 times 4 is negative 20. Negative 5 times positive y. Remember, a negative times a positive is just negative, so negative 5y. That's a little bit tricky, but you should be okay. Equals to negative 30. Our goal is to solve for y, so we want to keep y by itself. So I think we have to remove this minus 20, or negative 20, and the opposite of that would be to add 20. And that leaves us with negative 5y, and then negative 30 plus 20 is just negative 10. Looking good now, so negative 5 times y equals to negative 10. So to solve for y doing the opposite operation, we have to divide by negative 5. So then you get y, and what's negative 10 divided by negative 5? 2 negatives divided by each other gives you a positive. 10 divided by 5 just gives you 2. And there you go. Okay? So, let's see how you can think of a second way. All right? So, give yourself a few minutes to think about this. If you're not too sure, then come back and watch the tape. But if you can figure this on your own, I'd be very impressed. Okay? Think this algebra. Opposite operation. I see here negative 5 multiplied by, and in a bracket, 4 plus y. So do you hear me say that? Negative 5 times something in the bracket equals to negative 30. Remember, opposite operation. So what's the opposite of timesing? Yeah, if you said divide, you're correct. So perhaps what we can do here is we'll divide by 5 or -5 first. Okay? Because it's like me saying -5 times blah 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 equals to -30. So how do we solve for that blah 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 blah? Well, we have to get rid of the -5 first. So here we have now just the 4 plus y that's left over. You can put a bracket around it if you wish. You don't have to if you don't want to either. Okay. And this equals to, what's -3 divided by 5? That's, I think, +6. And so now, what is y? Well, we'll solve by subtracting 4. And 6 minus 4 is just 2. Same answer. Okay? Now, both ways work. I don't really care which one you do. But you might be thinking, the second way was cool. It looked like it's much quicker. Perhaps in this case it is. But if I were to change the numbers, like for example, if I change this -30 into -32, then you're going to have to encounter decimals sooner than later. And it's up to you. If you want to do it this way, you can, but you're going to get decimals sooner than later. Your choice. Okay? So, I'd like you now to solve the following exercises underneath with whatever method you wish. Okay? I want you to do it with an algebraic method, though. I don't really want you to be drawing pictures all the time. If you do need to draw pictures for the first one, go right ahead, but for B and C, I hope you do not. And then, once again, I'm going to ask you to try this on your own first, and then come back and watch the video to get the answers. Alright? Okay. It's your turn. Go. Isolate t, so we're going to divide both sides by -4. 8 divided by -4 is just -2. Ooh, fractions. Ouchie. No worries. Same thing. 1/2 times p. Half times 8 is 4. By the way, sometimes we write a half p as just p divided by 2, because 1 times p is p, so p divided by 2 plus 4 equals to 5. This should be something familiar with what we did last day, so we will now try to isolate the p by subtracting 4 off of both sides. P over 2 equals to 1. Our last step is to solve for p, so I want to get rid of that fraction, or dividing by 2. The opposite of dividing is multiplying, so p equals to 2.